In this video, we're going to look at more complex categorical variables. In the previous one, we looked at a case where there were only two possibilities, mechanical failure or electrical failure. Then we recoded mechanical as 1 and the other was 0, so that was good. So dummy variables, remember, can only take two values, 0 or 1. But what if there is more than two categories in a categorical variable? In that case, then we have to define multiple dummy variables for one for each category. So if there are 3 categories or 4 categories, then we have to define one dummy variable for each category, but not for the last one. Okay, that is, if you have k categories, you only need k minus 1 dummy variables. So for example, if you have 3 categories, you need only 2 dummy variables. If you have 5 categories, you need only 4 dummy variables. But the last one will be defined when all the dummy variables are 0, then that would then define the last case, the last category. So let's go back to the same example like in the previous example, in the previous video, and this one is not in the text. So now we have repair time in hours, x1 is number of months since last service. Now in the previous example, the type of repair was only mechanical and electrical. What if there are 3 types of repair, mechanical, electrical and electronic? Now in this case, there are 3 categories, so we have to define 2 dummy variables. Let's define d sub 1 as the first dummy variable equal to 1 if the repair type is mechanical, 0 otherwise, and d sub 2 is 1 if the repair type is electrical and 0 otherwise. Notice that if both are 0, then that would indicate that the category is electronic repair. So for 3 categories, you need only 2 dummy variables. If you define 3 dummy variables, then it will lead to an error. So you should define only k minus 1 dummy variables, where k is the number of categories in the categorical variable. So then our model will be x sub 1 and d sub 1 and d sub 2, and our predictor equation will look like that. So now let's look at the example in Excel. So here is our same data but revised. Now we're going to define the 2 dummy variables. D sub 1 is 1 if it is mechanical, 0 otherwise, and d sub 2 is 1 if it is electrical and 0 otherwise. X sub 1 is last service, which is the same. Now repair time is the same. Now we need to define if function for these 2 dummy variables. That is mechanical, it is 1, otherwise 0. Second if is, if it is electrical, it is 1, 0 otherwise. We copy that. Okay, whenever it is electronic, then both dummy variables will be 0. So the repair type is mechanical, d sub 1 will be 1, d sub 2 will be 0. If it is electrical, it will be 0 and that will be 1. If it is electronic, then both will be 0. Now let's run the regression. Click regression. Y range, repair time, X range, labels, and let's put the output right here. Click OK, and then format the output. So here are the coefficients. So y hat will now be, now for electronic repair, both D sub 1 and D sub 2 will be 0. So only that part will be your y hat. Now for mechanical, D sub 1 will be 1, that will be 0. So 2.25 minus 1.29 will give you the y-intercept. Now for electrical, D sub 1 will be 0, D sub 2 will be equal to 1. Now interpretation, B sub 1 is 0.34 hours. So we want to convert that to minutes times 60. The slope coefficient is about y hat. So y hat is repair time, so that's our repair time. B sub 1 is a coefficient for x sub 1, which is number of months since last service. So if number of months since last service increases by 1, then the repair time will go up by 0.34 hours or 20.4 minutes. B sub 2 is minus 1.29, and that in minutes will be now you have to be careful interpreting dummy variable slope coefficient. So B sub 2 is about the first dummy variable, which represents mechanical, and the 0 represents electronic. So the 0, 0, the category that is represented by all dummy variables 0, that is your base case, and all the slope coefficients must be compared to that base case. So the base case being electronic, so compared to electronic, this is what will happen to the repair time if the repair type is mechanical. So if it is mechanical, then it will take 77.6 minutes less compared to electronic for the same number of months since last service. Okay. Now B sub 3 is electrical. Okay, again, B sub 3 is 0.21 hours, and you want to convert that to minutes. 0.21 times 60. Now B sub 3 is the coefficient for dummy variable 2, which is for electrical. Once again, we have to compare electrical with the base case, which is electronic. So compared to electronics, electrical service will take 12.7 minutes or 0.21 hours more compared to electronic with this, for the same number of months since last service. So this is how you will interpret slope variables for dummy variables. You have to be very careful. You shouldn't say if the type of service goes up by 1, because that doesn't mean anything. If type of service is either 0 or 1, so you can't go up by 1, you know, from 1 to 2 or 2 to 3 or anything like that. So you have to be very, very careful interpreting the slope coefficients of dummy variables.